Okay, today we're going to talk about the Pythagorean theorem and its converse. So when we finish, we want to be able to use the Pythagorean theorem and its converse. Okay, so when we use the Pythagorean theorem, we use it when we have a right triangle. So the Pythagorean theorem is a squared plus b squared is equal to c squared, where a and b are the legs and c is the hypotenuse. So I'm sure that the Pythagorean theorem is familiar to you, but the Pythagorean triple may not be. So the Pythagorean triple, it's a set of non-zero numbers. Non-zero whole numbers. A, B, and C. That satisfy the equation a squared plus b squared is equal to c squared. Now let's take a look at some common Pythagorean triples. So 3, 4, and 5 make a Pythagorean triple. 5, 12, and 13. Then we've got 8, 15, and 17. And then we have 7, 24, and 25. So if you look at these, which one of these in each of these sets do you think is the hypotenuse of the triangle? So in this one, it would be 5. In this next one right here, it would be 13. What do you notice about all of these numbers? It's the largest number in each set. So let's take a look. So let's do 3 squared plus 4 squared, and let's see if it's equal to 5 squared. So what's 3 squared? Well, that's 9. What's 4 squared? 16. And what's 5 squared? 25. Now what is 9 plus 16? Well, that's 25. And last time I checked, 25 was equal to 25, so that is a Pythagorean triple. Notice that they're all whole numbers, and there are no decimals, there's no radical, there's none of that. Now the beauty of the Pythagorean theorem is if I have a right triangle, like I have here, if I have any two sides of a right triangle, I can find the length of the third side. So, and that's what it's asking us to do now. So let's find the length of AB. So I've got 2 legs. So let's do 20 squared plus 21 squared is going to be equal to c squared. Okay, so 20 squared is 400. 21 squared is 441. So all of that's equal to c squared. So that gives me 841 is equal to c squared. So the opposite of squaring something is to take the square root of it. So I'm going to take the square root. So c is equal to the square root of 841, which is 29. So the length of this side is 29. Okay, let's take a look at the next one. So now, let's see, we want to find the length of the leg. So we're looking for this leg over here. and it wants us to write our answer in simplest radical form. So I'm going to say I have x squared plus 8 squared is equal to 20 squared. So x squared plus 64 is equal to 400. So now I'm going to subtract 64 from both sides. So I get x squared is equal to 336. So the first thing I'm going to do is see if I can take the square root of 336 exactly. And when I do that, I cannot. So what do I get? I get 18.33. And so it's not a perfect square. So I'm going to do the method that works for me without fail. I'm going to do my factor tree. So 2 times 168 gives me 336. 2 and 84. 84 breaks down to 2 and 42. 42 breaks down to 2 and 21. And 21 breaks down to 3 and 7. So what's our rule? Pairs go out. Do green for go out. And singles stay home. So I've got 2 sets of 2's. So what's 2 times 2? That's 4. So I've got 4 times the square root of 21. And I get that by 3 times 7. So that is what x is equal to, and that's an exact answer. Okay, let's take a look at this next one. Okay, dog agility courses often contain a seesaw obstacle as shown below. To the nearest inch, how far above the ground are the dog's paws when the seesaw is parallel to the ground? Okay, so this seesaw, as the dog goes forward, is going to go up. Now, what height is it going to be when it's parallel to the ground? Well, it's going to be this distance. So is this a leg or the hypotenuse? It's a leg. I have a right triangle, and I know the Pythagorean theorem, so I'm going to be able to find out the height of that. So let's plug in our information. So I have 26 inches is one leg. I'm going to square that, plus b squared is equal to my hypotenuse squared, which is 36. So 26 squared is 676, plus b squared is equal to 1,296. So now I'm just going to solve. So I've got to get b, the variable, isolated. So I'm going to subtract 676 from both sides. So now I have b squared is equal to 620. Now it wanted me to do this to the nearest inch. So that means I don't need an exact answer. So when I take the square root, b is approximately 24.89, and there's a lot of numbers after that. So when I round this to the nearest inch, it is 25 inches above the ground. Okay, so now I'm back at the Pythagorean theorem. So what would be the converse? So the converse, remember, from way back when, we just changed the order. So if a squared plus b squared equals c squared, then triangle ABC is a right triangle, would be the converse. So if a squared plus b squared equals c squared, then triangle ABC is a right triangle. Okay, let's see can we determine if the triangle with sides 85, 84, and 13, is this a right triangle? Well, first I'm going to have to use some of my prior knowledge so I know where to put these numbers. So 85, 84, and 13. Which one of these numbers is the hypotenuse? 85. How do you know that 85 is the length of the hypotenuse? Because it's the largest, because it is opposite of the largest angle, right? So it's the longest length of the three sides. So now we've got 13 squared plus 84 squared, and I'm putting the equal just in case, is equal to 85 squared. If this statement is true, then I have a right triangle. So what is 13 squared? It's 169. Now what is 84 squared? It is 7,056. Now what is 85 squared? 7,225. So I'm going to simplify. I'm going to combine this. Notice I'm not bringing anything on. I'm keeping everything where it is. Okay, so I'm going to combine 169 and 7,056. And when I do, I get 7,225. Is 7,225 equal to 7,225? So yes, so 84, the triangle with sides 85, 84, and 13 is a right triangle. So we have some uses for the Pythagorean theorem, or a version of the Pythagorean theorem, even when we don't have a right triangle. So if we're trying to determine if a triangle is right or not, like we did up here, we could determine if it was a right triangle because these two were equal. If c squared is greater than a squared plus b squared, then we know that we have an obtuse triangle. And if c squared is less than a squared plus b squared, then we know we have an acute triangle. So let's go back and review. What is the definition of an obtuse angle? So that's an angle that's greater than 90 degrees. Okay, so what do you think the definition would be of an acute triangle? Or an acute angle? So that would be an angle less than 90 degrees. Okay, let's take a look and see if we can classify this triangle. So a triangle has side lengths of 6, 11, and 14. Wants to know if it's acute, obtuse, or right. So first of all, first thing I have to be able to identify is my C value or my hypotenuse value. What is it? It is 14. So 14 squared. I'm going to leave a little space saver there. Now what is my A value is 6 squared. My B value is 11 squared. So what is 14 squared? That's 196. 6 squared is 36. 11 squared is 121. When I add 121 and 36, what does that give me? That gives me 157. So is 196 greater than, less than, or equal to 157? It is greater than. So if I go back over here, then I know that that a triangle with lengths 6, 11, and 14 is an obtuse triangle. Now, one thing you have to be careful of is the setup, because I could have flipped these numbers around. Your answer still works the same, but you have to be prepared to realize that 157 is less than 196. You have to keep track of what your C value is. Even though I wrote it a different way, this would still be an obtuse triangle because C is greater than my A plus B. So C is greater than my A plus B. And that's all we have for today.